I hope the screen is visible to all of you.
Yes, sir.
Okay. And do all of you remember the ray diagrams?
Yes, sir.
Okay. Anyone who is not able to recall all the ray diagrams? See, we had done the image formation by concave and convex mirror. So just we'll quickly revise image formation. See, these were the various cases that we had seen for the image formation. Here we have. So here you have the images. Let's see. See all the ray diagrams which have been formed here. I think all of you can observe the images. Just one. These are the 6 cases of uh, images images formed. In the first case, you observe when the object is located at infinity. If you observe, if the object is located at infinity, the image is formed at focus in the first diagram. See? And all the light rays which are coming from infinity, they are parallel. Hence, after reflection, all the light rays, they meet at focus. So here in the first one, here you have the object is located at infinity. All the light rays from the infinity, they come parallel to each other. The reason why they come parallel to each other, because it's very far, and far off objects, light from far off objects, they appear to be they come parallel. So all the light rays, they come parallel to each other, and after reflection they meet at focus. So what type of image characteristics are here? Dharya, can you give me the image characteristics for this image, for the first case?
Yes, sir.
Can you give the image characteristics for the case 1?
Sir, actually, I need to visit. I joined recently. I need to watch the old videos off. So
Okay, see, here we observe that the light rays, they are coming parallel to the principal axis, and after reflection they meet at focus. So after reflection, all the light rays, they meet at focus. Since the light rays, they are actually meeting after reflection, they are actually meeting each other. So here the image that will be formed is a real image. So we have here formation of real and inverted image. We will also obtain the image to be inverted. So image is real and inverted. Also, the second characteristic, in the first characteristic, we stated the nature of the image. Then secondly, we give its position. We observe that all the light rays, they are meeting each other at focus. So the image is formed at focus. The image is formed at F or focus. Then about the size of the image, we will observe the size of the image to be very small or highly diminished. The image should be highly diminished or very small. Okay. So I'll just show you one image formation for this case that will clarify how the image is formed. Let's say uh, Basically, I want to show you some good images which can be obtained like this. They are the ray diagrams. No, I don't want the ray diagrams. No, they all are ray diagrams. Okay. Uh, so what you will be observing, let me see. It should be something like this. I think you will recall. It's here one of the images. Yeah, it should be something like this that you will see. Actually, you will not be able to observe the light rays. See here, you can see all the light rays, they are coming out from the infinity parallel. They are parallel to each other. And after reflection, all the light rays, they are meeting over here on this plate. So this plate is the screen. This is not the mirror. This is the screen. This is just a white screen placed over here. Okay. So all the light rays, they are meeting over here. And here you can see a small tree formed here. Can you see a small tree that's inverted? An inverted tree is formed on the screen. The light rays, they are coming from a distant object. So here the images which are formed, they are real and they are formed inverted. So here we have the formation of a real image on the screen. So this is the first case when you have the object at infinity, the image is real and inverted. It is formed at focus and it is highly diminished. So just we observe the image of the tree is very small and it is formed on the screen. So that screen is obviously placed at focus. Okay. Then in the second case, we observe here, in the second case, we observe that the object is now placed a little bit, it's moved towards the mirror. Earlier it was very far off. And now we have moved the object a little bit closer to the mirror. So now the light rays coming from the object are not parallel. So you have the two light rays which are coming towards the two light rays which are coming from the object. One of the light ray is coming parallel to the principal axis, and after reflection the light ray must pass through focus. The second light ray is passing through the center of curvature like this, and after striking the mirror it bounces back along the same path. So using the two rules that we have studied, that if a ray of light is incident parallel to the principal axis, it will pass parallel through focus. And if a ray of light passes through center of curvature, so this ray of light will revert back in the same direction. So the two light rays, they meet at a common point after reflection at this point. So the two light rays, they meet at this point after reflection, and hence a real and inverted image is formed. Okay. So Abhigya, can you tell me the characteristics of the image formed in the second case?
So it would be real and inverted,
Okay, it's real and inverted.
and
And
it's formed between C and F,
okay, formed between C and F.
and the image will be diminished.
Okay, image is diminished. Formed between C and F, and it's diminished. Means it's small. Then after that, we make the object move. Object means this AB that I have taken. This is the object. Now I take the object a little bit more closer towards the mirror, and now I place the object at C. So see here, you will find the object placed at C. At this point, you find the object. And again, using the two rules, I draw the ray diagram. So if I observe the ray diagram, here one of the light ray coming parallel to the principal axis, After reflection, it passes through focus. The other ray of light, which passes through the focus, the other ray of light which passes through focus, it becomes parallel to the principal axis. So we observe that the two light rays, they meet each other again. They are actually meeting each other. And here also we have the formation of a real image. Okay. So Abhinav, what will be the characteristics of this image?
The image is of same size, real and inverted,
Okay,
and
image is same size, real and inverted,
formed
and
let's see,
formed at C.
C.
Okay. So here we have real and inverted image formed at C and same size as the object. Okay. So in the similar way, we have all these cases. The concave mirror, it forms virtual image only at one case. Only at one case, that is when the object is placed between pole and focus. Okay. So Dhriti, what are the characteristics of the image when the object is placed between pole and focus?
So image will be enlarged and virtual and erect.
Okay, very good. So you have got this? Okay. Now we can check, there are just two ray diagrams with the convex mirror. With the convex mirror, a convex mirror always forms virtual and erect image. Let us see the image formation by a convex mirror. Image formation by a convex mirror, we observe that a convex mirror always forms a virtual image. Let's see. So for a convex mirror, if you observe, there are just two cases, and out of this, the most important is this one. There are just two cases. One, when the object is placed at an infinite distance, and the second, when the object is placed at a finite distance. So here we observe when the object is placed at a finite distance, what type of image is formed. So see, as we can observe here, okay. So as we observe here, when the ray of light is parallel to the principal axis, see, it's like this. The ray of light coming from the object passes parallel to the principal axis, and then it reflects back along the line of the principal axis. So it goes like this. Okay. So it came parallel and now it goes like this, away from the mirror. Okay. So actually it is passing in line of the focus. The second ray of light, we have drawn the second ray of light which is moving towards the center of curvature, and it gets reflected back along the center of curvature only. So the two rays of light, they never meet each other. They are moving away from each other. They never meet each other. Rather, they appear to meet. So now you can see they are represented with the dotted line behind the mirror. Can you see now that behind the mirror, the light rays, they are represented with the dotted lines. Actually, they are moving like this. So this is the ray of light moving like this. This is the reflected ray which is moving like this, which never meet each other. They are moving away from each other. But if observed, they appear to meet at a common point. So the two light rays, they appear to meet at a common point, and hence a virtual, erect, and diminished image is formed by a convex mirror. Okay. Now we come to the very important part, that is Cartesian sign conventions. Okay. So now your real part starts over here. With that, coming to the first rule. So here, all measurements are made from the pool. All the measurements will be making on the from the pool. Measurements above the principal axis will be positive. So all measurements which are above the principal axis are positive. Measurements below the principal axis are negative. Okay. So these are the two rules that will follow. One more rule which there, that is the direction of incident light. I will explain all this. Let's have a note of that. The direction of incident light is taken positive. So what all these mean to you? Now we come to what all these points mean to you. First of all, if you observe any mirror, all the spherical mirrors, whether it be concave or convex. So in all the spherical mirrors, we observe that there is a pole, right? And that pole let's see here. So here you have the pole. So first of all the measurements will be made from the pole. So measurements that are to be made, that will be made from the pole along this direction, and they will be made along this direction. So measurements will be starting from the pole. The second one, that all the measurements above the principal axis. If you are measuring above this principal axis, making any measurement above the principal axis will be considered positive. And any measurement made down the principal axis, like this, they will be negative. So it just simply follows our Cartesian sign convention. Remember, in the Cartesian sign convention, we had chosen like this. Our Cartesian sign convention works like this only. We have the origin, and from the origin, you take your x-axis, y-axis. Okay. Here you take x, y, y dash. Now, all measurements above this, they are made positive. Here you have all plus 1, 2. Here below you have negative. Towards the right, you have everything positive. Towards the left, everything is negative. Okay. So same thing we are following here. All the measurements that we will be making above the principal axis, they will be positive. Measurements below the principal axis, they will be negative. Now just taking these two concepts, measurements above the principal axis, measurements below the principal axis. On this basis, we will try to justify the values of magnification. Okay. The magnification is given by the formula height of image over height of object. Okay. Now, so if an image formed will be inverted, here we have the object. As we know that object is always upright, and here we have the height of image. So if you we observe here that if an inverted image is formed, so in inverted image form, that means it's real and inverted, and for that case the height of image will be negative. Yes, the height of image will be negative. Dharya, are you getting? Ayonija?
Yes, sir.
Okay. Siddhisri? Okay,
Yes,
see,
sir.
here, so for this case, if suppose I get the value of magnification as negative, so what does it signify? Will the image be real, inverted, or will it be virtual and erect? I
Virtual.
have, see, I am getting the value of magnification as a negative number. Okay. So see, I will get a negative number from this fraction only, height of image over height of object. Now I know that height of object will always be positive. So this number will always be a positive number. And now if the height of image is negative, then only I will get a magnification as negative.
Yes, sir.
Okay. So what does it mean? What can we say about the image? Is the image inverted or erect? The height of image is negative. So it means the image is inverted. Okay. So if you have magnification as negative, it means or it applies that your image is real and inverted. Okay. If you have magnification as a positive number, any positive number, so it simply means that your height of image is positive, because if the image is virtual, so it will be formed something like this. This will be your height of image, and now it will be a positive number since it is a measurement above the principal axis. So this image will be a virtual and erect image. So from the values of magnification, we can justify whether the image formed will be real or virtual, whether it be erect or it will be inverted, just from the sign of the magnification. Okay. Then the value of magnification will give us more meanings, will add more meaning to it. For example, consider this. Consider these magnification values. Magnification equals -3, magnification equals 1/3, magnification equals -1/3. Okay. So what does this first point mean? Magnification equals -3.
That the image is
Hmm?
real and inverted.
Image is real and inverted. And what else?
It is magnified.
It is magnified. So from this value, we consider that image is real and inverted, and it is magnified. Okay. What do we mean by the second? What information we convey from the second value? Magnification 1/3. Yes. What information we obtain from here? Magnification equals 1/3.
So yeah, it is real and inverted and diminished.
How it's real? You have magnification value plus. There are no
Achha,
sign. That means
it's virtual and erect.
okay. So it is virtual, erect, and what about the size?
Diminished.
Diminished. Virtual, erect, and diminished. This is what is understood by this. What about this third one?
It's real and inverted and diminished.
Okay, real, inverted, and diminished. Dhriti, can you tell for this magnification +3?
So it means that uh, the image
Yes,
is real and erect, and it is
real and erect or virtual and erect.
so sorry, virtual and erect.
Yeah, it's virtual and erect and
Magnified.
it's magnified. Okay, so now I have some questions from other people who did not speak. So here I have one from Aryan. Aryan,
Yes, sir.
so Aryan, which mirror can give you the magnification as -3?
Concave.
Concave mirror. Under what circumstances? Which case of this? Where will you place the object so that you can get the magnification as -3?
So I think between C and F or
Yes,
F.
it's between C and F. If you place the object between C and F, say here, this is the case. When you place the object between C and F, this is D1. When you place the object between C and F, you are getting real, inverted, and enlarged image. Okay. So +1/3, it's here, convex mirror. See, the image is virtual, erect, and diminished. The same thing we have written here. Virtual, erect, and diminished.
Yes, sir.
Okay. So from the magnification value, we come to know everything, all the characteristics of the image. We come to know where the object is placed. Okay. We get everything about it. Now, the next part of the sign convention, this was all about magnification, height of image, and height of object. I hope everyone has understood these points. Anyone having any doubt? Meher?
No, sir.
No. Okay. So now we move. The next part is sign convention regarding the object distance, image distance, and focal length. So here we will apply sign conventions for object distance, image distance, and focal length. Okay. See, so sign convention as applied for these things. If we have any spherical mirror, so here we consider both the spherical mirrors. We consider the concave as well as the convex mirror. So let us make this one as concave mirror and the second one as convex mirror. So here I am shading it on the outside. This becomes a concave mirror and this one becomes a convex mirror. So for both the ray diagrams, for both of them, where we will place the objects, let's see. So for this one, we will place the object on this side of the mirror. We will be placing our object somewhere here in front of the mirror. For this, we will be placing the object somewhere here in front of the mirror. Now, as we know that all the measurements are to be made, from the principal axis. and the direction of incident light is taken to be positive. So here we have the incident light. So let's say this is the incident light, this is the object. So light on the mirror falls from the object like this. So this is the direction of incident light. Here I have the object located here. So this is the direction of incident light. Now all the measurements that I will be making in the direction of this light, they will be positive. If I make a measurement opposite to this light, that will be negative. So for this mirror, if I measure the object distance, so object distance will be measured from pole to the object. See, this is your object distance. It will be represented by the symbol U. So what sign convention should be applied to U? Should it be positive or negative?
Negative.
Negative. The object distance is measured in opposite direction of this incident light. So this will be negative. Okay. What about the focal length? Which will be measured from pole to focus. So this is the focal length. What about the focal length of this mirror?
It will also be negative.
It will also be negative. Okay. Now for this mirror, if I measure the object distance, so what should be the sign convention for object distance? Since the object is located here, now I measure the object distance. This is the direction of incident light, which will to be the direction of incident light to be taken positive. So what sign should be applied to the object distance in the convex mirror?
Also,
Positive.
Is it in the direction of incident light or opposite to the direction of incident light?
Negative.
Negative. This is also opposite to the direction of incident light. So this will be negative. Here also the object distance will be negative. Okay. The measurement of focus or focal length from here. What about the focal length?
negative.
See, the focal length is now made in the direction of light. This is the direction of incident light and we are measuring in the same direction. So here focal length would be positive. Here focal length is negative. Here focal length is positive. Okay. So for both the two cases, we have object distances are negative, but focal length for convex lens is positive and focal length for concave mirror is negative. Okay. Now similarly, we can see the image distances. For this case, the image is formed over here between F and P. So the image distance would also be positive. For the concave mirror, if the image formed is virtual, if the image is formed somewhere here virtual, if the image formed is virtual, so we will say that the image distance is positive. If the image formed is real, if the image is formed on this side, if the image is formed somewhere here, so then we will take the image distance as negative. So anyone having any doubt regarding all the sign conventions? Anything about the sign convention? Any point you are
Sir.
lagging about the sign convention?
Sir, in the case of convex mirror, like values which are facing with the incident ray are positive and opposite are negative.
Yeah, for both of them, it's the same thing. Okay. Now see, you are getting confused because I have drawn the mirror like this. Okay, let's draw the mirror in other way. Then all of you will not have any doubts. So if I draw the mirror like this, I'm again drawing the convex mirror like this, and then you will say that yes, it's correct. Okay. So let's draw the convex mirror again. Okay. So here I am drawing a convex mirror again. So now it's something like this. And I polish it from inside. So now it's the convex mirror. Okay. So I keep the object over here. I keep the object here. The direction of the incident light would now become like this. So this is the direction of incident light. If all the measurements are to be made from pole. Now you will have your focus here and center of curvature here. Okay. So now if you observe the focal length, image distance, and object distance. So what can you say about the object distance?
It's negative.
Negative. Focal length,
Positive.
positive. What about the image distance?
Positive.
Positive. So now you have understood?
Yes.
Yeah, it's the same thing. It's the way you draw the diagram. Even if you are drawing like this, again the values hold the same sign conventions. Okay, it's not our left and right. The left and right is chosen on the basis of the direction of incident light. Okay, so today I'll be posting you some of the questions in the group. Do try to attempt those questions. Okay, and clarify your doubts. See previous lectures. Clarify your doubts. If you have any doubts, do contact through the support group. Okay, if you are having see in the support group, I cannot explain you everything, but if you have doubt regarding any question or anything, you can post that question in the support group. Or you have a separate science doubts group. I hope you must have got the link for that. Okay, so you can post your questions over there. So as soon as possible, I'll try to revert back to your questions. Okay, so bye everyone.
Bye.